Hi everyone, I'm Patrick Arlt, and I'll be joined by Gavin Rickemper and Jacob Weselkowski. We're going to talk about building web apps with open source mapping APIs. And the three that we're primarily going to cover today is we're going to take a look at Leaflet and the Mapbox, MapLibre GL libraries, and then we're also going to take a look at OpenLayers. And the reason we're kind of focusing on these three is that these are the three most common of the open source mapping APIs. They all kind of share smaller modular footprints. They all have fairly simple, straightforward APIs, and they all have big ecosystems to choose from with lots of plugins, lots of open source support, and things like that. Now, there are a couple reasons, though, not to necessarily choose these if you're building an application. I think it's important to get this out of the way right now, is these don't have support for a lot of the more ArcGIS centric concepts. So you're not going to find things necessarily like web map support or built-in support for ArcGIS identities, like authenticating ArcGIS Online users. And they don't have extensive support for some of the more specific service types. So if you're looking for something like stream layer or image layer or dynamic map layers, they don't necessarily support all the types of services, but there are ways to get them to use some of your hosted data, and we're going to go over that later. And then the last bit is, especially in the case of Mapbox GL and OpenLayers, there's no direct integration with any of the ArcGIS REST APIs, although you can use REST.js. So primarily what we're going to talk about today is we're going to talk about basic mapping. We're going to talk about routing, geocoding, and demographic data using those kind of core location services. And then we're also going to talk about vector tile layers, and specifically rendering vector tile layers and styling them. So this is really kind of where the main focus of this is going to be. Now, there are a couple additional things that are part of the Esri Leaflet plugin. Esri Leaflet does support feature layers, and over the last year got support for the same kind of heavily cached tiled feature layers that the ArcGIS API for JavaScript supports. And it also has some rudimentary support for working with map services and image services. It also has things like a pre-built geocoding control, and it has support now for vector tile layers. So there's a lot of additional things in Esri Leaflet that do make a lot of sense and open up more choices for building applications while still keeping the footprint modular and small. So kind of to summarize, you need to think about the capabilities that your app is using for this. Do you need the tighter integrations? Do you need some of the UI widgets that are part of the JavaScript API? Do you need 3D? Do you like the 100% kind of WebGL rendering, or do you want a really small, light footprint? Do you need access to that open source ecosystem? If that's a requirement for you, then the choice should hopefully be clear between choosing one of these over the other. And then some additional questions to ask is, if you're building an app that utilizes authentication through ArcGIS Online or ArcGIS Enterprise, and you're really heavily making use of that identity to access items and content and share things, if you need web map support, those are both great reasons to use the JavaScript API. But if you're only consuming the basic location services, then these are really going to be a good option for you, and it might be worth considering using one of these open source APIs. So we're going to get into some demos now, and Jacob is going to start us off with some demos in Esri Leaflet.
So what we'd like to do now is take you on a tour of using Esri Leaflet with ArcGIS location services. Through this, I'll walk you through a few demonstration tutorials to give you a taste of what's possible. First off, let's start with something straightforward, a Hello World demonstration. Here we'll just create a new Leaflet.js map, and we'll add a vector basemap layer to it. So first we have to start off with obtaining an API key and inserting it into our code, deciding which ArcGIS style basemap we want to use, In this code sample on line 4, we can create a Leaflet.js map with an initial location and zoom level. And then on lines 8 through 10, we'll add a brand new vector basemap layer using that API key and add it to the map. We have a fully interactive Leaflet.js map with that vector basemap layer. Let's take a look at the code ourselves. In our HTML document, we start off with loading Leaflet from CDN, both its CSS and JavaScript requirements, as well as Esri Leaflet JavaScript files. Down in our custom script tag, you can see that it's waiting for us to insert our API key in order to be able to load that vector basemap layer. So let's do that. Give it a moment to rerun the code. There we go. While we're at it, I'll start the default zoom a bit further out. Maybe change our location. And let's try something else. ArcGIS : imagery. All right, hello world. Let's do something slightly different. What if we want to show a We're still importing Leaflet files, Leaflet plugin files, and our jump back over to my code pen and paste it in and let the code refresh. So let's add a little bit more here to our user that lets your users search for an address. The Esri Leaflet plugin also has geocoding control that you can add to a Leaflet.js map. In this code snippet, we're creating a new that's the L dot. Then we for the search control. At that vector basemap layer. Including that ArcGIS REST.js helps with authentication while we. So what we'll do is for every Leaflet.js be reached in a given driving time from that location. And as each polygon gets bigger, we have a visual indication. So we'll import a leaflet, Esri Leaflet, and ArcGIS REST.js to help us do all these things. Examples waiting for that API key. It's establishing a base map, previous features on the map. We add source point at that click location. And then finally, we make that API request with the help of ArcGIS REST, the service area module. With ArcGIS REST.js and Leaflet. Let's look at the relying on a map click handler to fetch REST.js's query demographic data function. Then when that network response comes back to us, we'll set the pop-up content. Let's do one more. The difference between Warszawa and Krakow. Have about 66,000 people. So as you can see, there's a lot we can do here. Services, and we're just scratching the surface.
So I want to go over some of the technology, and we'll get to why this is kind of a split section. Most of what I'm going to find at developers.arcgis, Mapbox GLJS, also all of So I want to get started shortly before we. Mapbox split their open source offering for release their 2x version. The 2x version of Mapbox GLJS is not actually open source. It requires an API key from Mapbox to work there. And this has kind of led to an open source fork led by MapLibre. And so the demos that I'm going to show today are really for the 1x version of Mapbox GLJS, or potentially for MapLibre GL. This hasn't been tested, but release of Mapbox GLJS 1.13 with some doubt. So that's why there's this split. Going forward, we're going to focus a little more on MapLibre and Mapbox, the 1x series, to try to make sure that our documentation is compatible with those. So the first thing that most of you will want to do with an application like this is we're going to want to get something like a base map and some basic services set up. And that's essentially what this demo is right here. So in this demo, what we're going to look at is we're going to look at just building this little application, this little geocoder. And this essentially is a pretty basic application. But this is something that just kind of shows the services and shows how the integration works. So this loads Mapbox GLJS. We're also using ArcGIS REST.js to do the interaction with the geocoding API. So we need the base request and auth libraries as well as geocoding. There's some basic CSS styling in the demo, which is important. And then we do use the new API key implementation. So this is new as of the end of January. API keys are publicly consumable strings. You'll see similarities to other platforms here. You can go and register a key, and then it's your responsibility to monitor it for usage. And we see that we're using the new style service. So this is the new service, and this is going to request type equals style. And this returns a Mapbox GLJS compatible style representing the navigation style in ArcGIS Online. And if I zoom out, you'll see I get the nice navigation style that we have. And then we can implement the geocoding control. And the geocoding control is really just a class with an onAdd method, and we can add it to the top left, and we get the response back, and we can use that to interact with the map. So this is essentially the most basic demo. We create a new map. We point it at our navigation style with our API key, and that returns a valid style that we can then render. So going forward, I'm going to spend quite a bit of time talking about hosting and querying your own data. So in this example, you can see I've run this query here, and we can add a second query, and that'll select shapes from data that we've actually published to the ArcGIS platform. And this works in largely the same way. So the data that we published is going to be in a feature layer, and we're going to use ArcGIS REST.js's feature layer tools to get access to that. So we have the same setup. We have an API key. We're using the streets base map. We create a GLJS map. We're going to use the built-in GL drawing tools. We're going to add those. And we're going to add a source. And in GLJS, a source is essentially any source of data. So we are going to add a source of GeoJSON data, and that's going to be an empty feature collection. And then we're going to essentially add other layers for our drawing tools. And then we're going to instantiate this parcel layer that we're going to fill with the results of our query. So we're going to query the parcels intersecting or within our shape, and then we're going to create an empty kind of layer for that. And when the map loads, we're going to add all of those additional pieces. And then when we actually create a new shape, we're going to use Terraformer, which is another open source offering from Esri. We're going to turn that into a corresponding ArcGIS geometry, and then we're going to use that geometry with REST.js to actually do the query. So we're going to take the geometry that we draw, and we'll turn that into, from GeoJSON, which is how GLJS gives it to us, we're going to turn that into an ArcGIS geometry, and we're going to pass that to execute query. Execute query is going to query features from the feature layer that we have hosted in the ArcGIS platform, and we're going to get out all those geometries, and we're going to get our parcel source, and we're going to set the data to the response. And this works because we allowed you to query GeoJSON out of the platform. So we'll request GeoJSON. We want all features intersecting this polygon that we just drew. And then when we click on these, we can actually see that we can find out that that's irrigated farmland. So that's some basics of hosting and querying data. So we have a layer in the background. We can use that underlying service and we can query it for data. Now, you can also create and host vector tile layers inside of the ArcGIS platform. And this is important because that's mostly how a library like GLJS operates. So this is actually composed of 3 different layers. We actually have a layer for the trailheads, we have a layer for these trails, and then we have a layer for these park polygons. And you can composite and combine these just like you would regular vector tile layers inside of Mapbox GLJS. So this is an API key that we're using. We also have a custom map style, so you can also customize the look and feel of these base maps. So this is a custom style, and I'll go into how I created that in a second. And you can actually just use the identifier for that style on the style API, just like you would an identifier like in the previous demos for ArcGIS streets. So that you can substitute in your custom identifier for that. You'll get one when you create your custom style. And then when we load the map, we want to add the parks and open space source. So we're going to start from the back, and we're going to add our parks and open space. We're going to point it to a source of data, and this source of data is a layer that we've got published in the platform. And I'll go into how we've created that in a little bit. And then once we have the source of the data called parks and open space, we can add a layer that refers to a specific layer inside that source. In this case, there's a layer that's parks and open space, and we can define how we want to paint that layer according to the GLJS API. And then we can actually just repeat this process for the trails. We need a data source for the trails. We need a layer to represent the trails when we add those. And then we add a second for the bike trails. You'll see some trails have this dotted line inside them, and that we're using that to represent bike trails. So we can actually add the layer that looks at the same source again. And then for our trailheads, we want to have the kind of standard hiker icon, so we can get that off of the ArcGIS CDN. So we'll add that as a icon that GLJS can understand. And then we'll add our trailheads layer, and we'll tell our trailheads source and layer to reference that icon. Now, one key thing here is that this data that I'm accessing is actually private. So starting with the last release that we did at the end of January, if you have an ArcGIS developer account, you can use an API key to read private data. That's currently in beta, and we'll be announcing a pricing model for that later. If you're an ArcGIS Online organization, you don't have access to this, and to access private data, you're going to need to do the usual process of doing OAuth 2 to get an ArcGIS identity, and then going through the process that way. But in both those cases, you're going to get a token, and you can pass it to the tiles to get the private data. So how did I set all of this up? And the data actually comes from one of our tutorials, which is import data as a feature layer. And you can find this in the Mapping APIs and Location Services guide. So if you go to the developer site, you go to Documentation, Mapping APIs and Location Services, and then drill down into the data chapter. We actually make this data available to you, and we'll tell you how to import it. And once you import it, you'll end up with a whole sequence of layers. So this is the Trails GeoJSON file that is part of that data. And that you can, when you upload it to the developer site, you can import it and find it. And when you do that, you can then generate a feature layer. And once you have a feature layer, that's actually backed by a service that you can query the data for, which is what we saw in this demo. But if you want to get it as vector tiles, you can actually publish it as vector tiles. And if you go into the details of your layer, you can publish a vector tile layer. And you can do things like select which fields you want to publish, and you can use this to create vector tiles. So this is the vector tile version of those trails. And if I go into view details, you can see that we actually give you kind of a default style. And this is exactly what I'm copying into my parameters to plug into Mapbox GLJS. And I'm tweaking the rendering a little bit, but this gives you the basics. And this source layers is where you can actually go to see what the different layers inside this vector tile data source is. So in this case, we only have a single source layer called Trail 0. And to manage access to this, because you can see it's private, it says authentication required, I actually created an API key that is allowed to access this content and items. And it's got access to 4 right now. It's got access to the basemap, the parks, the trails, and the trailheads. And it also is what I'm using for basemaps, and it also has the ability to do geocoding and routing. So this kind of wraps up all of that access and permissions in one API key. So this is how you can kind of get access to private data if you have a developer account. Now for the custom basemap, there is a new set of tools that we released last year. If you want to create a new vector basemap layer, you can go into Vector Tile Style Editor, and you can start actually customizing some of our existing basemaps. And when you do this, you'll get an item ID that you can substitute in for your style. And so when I save this, I get an item ID, and I can actually take this item ID over to my map and use it. So if I go back, I'm going to share this publicly. I'm going to grab that item ID, and I can plug the item ID in as my style. And now we have a brand new basemap style. So that's how you can kind of go end to end, customizing everything, hosting your data in ArcGIS platform, rendering it out in GLJS. And so just to wrap up, the raw queries to endpoints are rate limited. So there's some special tooling in some of the APIs, like the JavaScript API and Esri Leaflet, that reduce the query volume for public data. Mapbox and OpenLayers don't have that. So if you're building an application that you expect to be fairly high volume, you're going to want to publish that as a vector tile layer. And really, the kind of preferred workflow should be publishing as a vector tile layer. And then you can also leverage ArcGIS REST.js for your service interactions.
OpenLayers is a JavaScript library for displaying map data in web browsers. There are many mapping apps out there using OpenLayers, and if you're already using OpenLayers, you might want to be able to use the Esri open source mapping APIs with the OpenLayers library. I'll go through how to do that here. To create a basic Hello World app that includes an Esri vector tile layer base map, first we include the OpenLayers library by importing the CSS and JavaScript. We also import the OpenLayers Mapbox style library. This library, sometimes shortened to OLMS, allows adding a vector tile layer with a style specification, which is what we'll get from the Esri endpoints. The key code for the app is here. We create a new OpenLayers map passing the ID of the DOM node we'd like the map to be placed into. Then we set the initial center and zoom of the map with the setView function. Then we build up the basic map style URL using the API we get from developers.arcgis.com, the basemap ID string indicating what style of basemap we want, in this case the streets basemap, and put both of those strings into the URL hitting the basemaps API.arcgis.com endpoint. This URL will return back a vector tile style JSON that we can pass directly to the OLMS library, which will add it to the map. So let's see that in action. Here's a CodePen code sample with that code in it. As we mentioned, we've included the CSS and JavaScript for OpenLayers and included OLMS. We've created a div that contains an ID of map, which is where we'll place our map. We've added some basic styles so that the map takes up the full area of the window. And in our JavaScript, this is the JavaScript we just looked at, being sure to place a valid API key from developers.arcgis.com. And we're placing our basemap ID and our API key into that URL. Now we have a working map. I can zoom in, zoom out, and we've got that map in place. We could change the basemap style to say topographic, and the basemap is immediately changed. So let's take a look at adding a feature layer. The next thing we might want to do in our OpenLayers map is to add a feature layer to the map. Feature layers in ArcGIS Online can be returned as GeoJSON, so we'll use the OpenLayers vector source and vector layer to display GeoJSON. Switching over to our CodePen. After the base map is added to the page, instead of putting this console.log, we'll go ahead and use the ol.source.vector to create a new vector source based on the URL of our feature service. Here's the feature service URL, and the key piece is this f=GeoJSON, which is going to export or output the features as GeoJSON. We then take that source and put it into an OpenLayers vector layer and simply add it to the map with the add layer function. Now we can see all of those points that are added to the map. For our last OpenLayers demo, we're going to do some routing. This sample will be a little bit more advanced. We'll add a button to our map. We'll wire it up so that when the button is clicked, we will take two random points from the points layer and get a route between those 2 points using the ArcGIS REST.js library and show the results to the user. This will involve transforming data from WebMercator to WGIS84, as well as showing data in multiple layers, the points as well as the route result layer. So let's jump in. First, we'll import the ArcGIS REST.js library. We'll import the routing and auth packages. Then we'll add a button to the UI that will allow us to click to generate the route. Next, we'll add some CSS styles to place the button into the top right-hand corner of the map and add some other styles. So now we've got a button up here. Finally, we'll work on the JavaScript. We'll add a click handler to our button so that we have a function that we know will get called when the button is clicked. We want to loop through the points, showing a route between 2 different points each time the button is clicked. So we'll create a variable called I that will track which index of the points we're currently on. Now if we open our developer console, When we click the Route Me button, we can see our I index variable increasing, which is just what we want. Next, we'll take care of the initialization. We want to create a new layer to hold our route, and when the points layers loads, we want to store those points in a variable we'll call all features, so that we can loop through those points when the button is clicked. So here we're going to call a function called add route layers, and we'll populate all features. To define out that function, we'll go to the top, add route layers, creates a new vector layer. We're applying some styles, and we're adding it to the map. Next, let's add the code that actually calls the REST API to get the route. This will be in the button click handler. Back down here where we created that. Now this code is a little more complex. We're first clearing out the route layer, and we're creating the start and end coordinates to save for later. We then use the ArcGIS REST API, passing our API key, and calling the solve route, passing our initial coordinate and our end coordinate, as well as our authentication. That then calls the REST endpoint, resulting in a response that we can convert to GeoJSON, and then we display that GeoJSON in a vector layer and set the route layer source to display it. All that code means that when we click Route Me, if we zoom out, it'll find 2 of the random points and find a route between the 2. Now we have a problem here that the points might be close together, so it's hard to tell where the route is being placed. What we can do next is zoom to the route when I click the button. So let's do that here. Back up in the initialization, we'll add a listener so that when the route layer changes, it gets the extent, it checks if it's a valid extent, and if it is, it sets the map using the get view and set view functionalities. So now when we click Route Me, it'll zoom to my route. Today we've shown you how to use the open source mapping libraries with the ArcGIS platform. Whether you're building with Leaflet, Mapbox GLGS, or OpenLayers, you can use Esri basemaps, feature layers, geocoding, routing, and other geoservices all within your current app. Esri has plenty of resources for learning about these topics. For Esri Leaflet, there are tutorials at developers.arcgis.com. You can find the documentation for Esri Leaflet out on esri.github.io/Esri Leaflet. GeoNet community for questions and answers over at esriurl.com/community Esri Leaflet. And the code is open source on GitHub, where you can find that. It's at github.com/esri/Esri Leaflet. The Mapbox GLJS resources include tutorials out on developers.arcgis.com and a community on GeoNet for questions and answers. OpenLayers also has tutorials on developers.arcgis.com, as well as question and answers on the GeoNet community. Thanks for listening, and please provide feedback for this session by clicking on the session survey link directly below this video. Thanks.
Hi everyone, I'm Patrick Arlt, and I'm joined by Jacob and Gavin, who we were just giving the presentation. We were aware that there were some audio issues during the presentation, so this it was pre-recorded, so it's going to be available, I believe, immediately after the presentation, or at least shortly thereafter. So if you did encounter some audio issues with the live stream, you can go back and rewatch it. So I do want to address, we got a lot of questions about the migration procedure for existing applications using the new API key requiring services. So I want to clarify the cases in which you are required to migrate. You are required to migrate all applications if you have an ArcGIS developer subscription. So if you signed up on the developer site and that's what you use for development, you need to migrate all of your applications. And I believe we are extending the deadline for that. I think there's going to be an announcement sometime later this month with the new date at which you have to migrate by, but you are required to migrate all your applications if you only are using a developer subscription. If you are not using a developer subscription, for example, if you're part of an ArcGIS Online organization and you have an ArcGIS Online subscription, you only need to migrate commercial applications, so applications that you're generating revenue from. In that case, those revenue generating apps are not covered in your ArcGIS Online subscription. So you need to actually migrate those over to use credentials from a developer subscription. So that should be kind of an edge case. But the old services are not going to be disabled or cut off at this time. We don't have any plans for that. So things are going to continue to work, but you do need to migrate to be in compliance with the licensing. I also wanted to address some of the other questions which were related to the number of free base maps. The number of base maps that you get is dependent on not the API that you're using, but on the subscription type that you have. So you get 2 million basemap tiles with a developer subscription for free every month. That's regardless of whatever API you choose. Depending on the API, you might use more or less tiles, depending on how that API decides to request tiles on your behalf. So it will vary slightly the number of tiles you use, but the number is consistent. If you have an ArcGIS Online subscription, that's the same as it always is. You essentially have unlimited base maps. So I wanted to address that. And it is a little difficult to estimate the tile usage. We're working on an estimator app that'll give you a better sense of how many tiles are requested by a given API at a given screen size. That's probably going to be on the developer site sometime later this year on the pricing page. So we did get at least one question about the Esri Leaflet GitHub Pages site. So there is kind of the old documentation site for Leaflet. That's still very relevant. That's where the API reference and a lot of the examples are. We're working on keeping that up to date. We're also considering moving it over to the new doc platform we have on the developers website. That's still kind of in the early planning stages between me, Gavin, and Jacob. But the doc that's on the developer site and the doc that exists on GitHub Pages are both relevant for the latest version of Esri Leaflet. So there isn't really a split between the old and the new in terms of the doc on those two websites. They're both very relevant. We got a question on, is it possible to customize raster base maps with the vector tile style editor? And it is not. The raster base maps are just, that's only the styling and the data is kind of baked into the single PNG, so you can't really edit that at all. That's one of the big benefits of vector tiles is the data and the presentation of the data are decoupled from each other, so you can just customize the style but keep using our own data. So I would just recommend moving to vector tiles in that case. This question, I know this was also asked in the ArcGIS platform chat, would using Leaflet or GLJS instead of the ArcGIS API for JavaScript negatively impact our Esri partner status? I know that was asked in the platform chat, and Ewan reposted that in the platform Ask Our Experts area and answered it there. The answer, and I copied his answer below in that. So the third-party APIs are fully supported when used against ArcGIS platform, so your partner status is not affected. So you're free to use those without worrying about your partner status. We got a question on, is it possible to authenticate a private ArcGIS Online vector tile layer through OAuth? And it is. There's a tutorial that I linked in in the answer to that question on adding a vector tile layer, the thing that's secured are the tiles. So you need to pass the token for that you got via OAuth to that tile URL, and then that will actually allow you to request the tiles inside of Mapbox GLJS. So it's really just appending that token to the tile URL would let you access that. Can a leaflet map be used with portal? This one's, it depends on what you mean by portal. If you mean, can you make requests to portal for stuff and show them on a leaflet map, then the answer is yes. But leaflet kind of, as a nature of how it is it's very different in scope. So we don't have a lot of things like web map support or built-in identity management or support for a wide variety of renders that you might find inside portal items. So a lot of the individual kind of bits and pieces that you would kind of expect to work don't in Esri Leaflet. So depending on your application and the capabilities you need, it might be possible. But in general, if you're building an app that really deeply relies on a lot of stuff in portal, we kind of recommend using the JavaScript API. I don't know, Gavin or Jacob, if you want to jump in there at all.
Yeah, no, that sounds correct.
So we got a question on in the new platform changes, will the API key work for feature service access? API keys can be allowed to access feature services, but only if you have an ArcGIS developer account. So if you have a developer account and you have a feature service on there and you want to be able to load that feature service, you can allow an API key to access that. And I talked about this a little in the authentication session I did yesterday. I'll find the recording and link to that in the response to this. But generally, yes, you can access feature services. You cannot if you're in an ArcGIS Online organization. We want you to use the ArcGIS Online kind of sharing model in that case. So you would authenticate via OAuth and share it with users.
Patrick, one of the questions that came in, I think we've gotten this question a few times over the years. Are there plans to add web map support to Esri Leaflet?
Let me run that one. No, mainly because the web map specification is really, really big at this point. It takes, dozens and dozens of engineers inside of Esri to get it just to work in things like the JavaScript API and the runtime. We don't have those kinds of resources for Esri Leaflet. Implementing the whole web map stack also means supporting all of the renders, all of the layer types. So it's not just about like, oh, we can read the web map and find the layers in it. It's, well, what if you have the new above and below render that Jeremy showed during the plenary? We've got to support that. What if there's the new stream? What if there's a stream layer in the web map? We've got to support stream layers. So there's a lot of stuff that's in the web map spec that's really difficult to support. So we've kind of drawn the line at web map support, and we'd really recommend going with the JavaScript API if you need that. We've gotten this one a bit too, is it possible to convert a raster base map into vector, for instance, imagery? And this is an interesting question because the structure of the imagery base map is actually a vector tile layer, which is the labels, over the imagery layer. So in the vector tile style editor, you can load just the labels part of the imagery base map and customize just the labels. And there's a session on styling with the vector tile style editor where you should be able, that should cover not that exact use case, but the general steps. So you can go through and just say, I want the imagery tiles, and then I also want my custom labels to go on top of that. And I'd be happy to go into that a little more in the ArcGIS platform area if you want to ask there as well. So it's not all compressed into one into one stack. The imagery is separate from the labels. So if you just want to customize the labels, that's something that you can do. So I don't know if there aren't any additional questions. I think we can end this. I'm going to fill in some of the answers for the remaining questions, and then I think that's it. So thank you all for listening. I'll be in the ArcGIS platform Ask Your Experts, and I think Gavin and Jacob, you're keeping an eye on that too. So if you have any additional questions, feel free to drop by there and ask them. Thank you.